Assalamualaikum and greetings to Dr. Abu Ubaidah. So my name is Ahmad Qayyum bin Ahmad Jahan, and I'm going to show you the first exercise for this lab 3, which is the title is about the short transmission line. Okay, so this is the question inside the lab sheet where it's divided into two, where A it asks for the 381 MVA at 0.8 power factor lagging at 220 kV, and then for B 381 MVA at 0.8 power factor leading at 220 kV. Okay, so as you can see, the one written in the blue color here is the program. Okay, so for this one, just copy the program, and then you can see here I have put the program inside the script file. Okay, so after you have put the program inside the script file, save it, and then just run as usual. Okay, so as you can see here, this is the my command window is empty right now, so I'm going to run this program. Okay, so I have pressed the run button. Okay, and you can see here at the command window I have get the value. Okay, where you can see under this command window, it shows the value for A, where it shows the value of the VSLL, where we get 250.0186, and then the value of SS, where we get 3.2280E plus 002 plus 2.8858E plus 0.2I, and then we get the value of REG, which is 1.3645, and then the value of EFF, which is 94.4252, and then it displays the result for B, where we get the value of the VSLL, where we get 210.2884, and then we get the value of SS 3.2280E plus 02 minus 1.6862E plus 0.02I, and then we get the value of REG, which is negative 4.4144, and the last value we get the value of EFF, which is 94.4252. So that's all from me. Thank you.
Hello everyone, my name is Aliwan Amino with match number TH16162, and now I will explain the medium transmission line and the simulation of medium transmission line in lab 3, which is modeling of transmission line. So this is our question, and this is the program given in lab sheet. Also the manual solution here, we can see the value of inductance, which is 1.29 mH, and for capacitor also the value is 0.009 microfarad, and the resistor is 32 ohm. So by using the MATLAB software, so this is our program of medium transmission line that we copy in the sheet. So we save it in AM file. So we try run the program first. After we run the program, we need to enter the length of line, receiving voltage, power, and power vector, also the value of L, R, and C. So we enter the value. So this is our value of length of line, and this is the value of voltage, and this is the value of the power. This is our power vector, which is 0.8, and this is our value of inductance, and this is our value of resistor, and the last is capacitor value. So after that we enter, and you can see here the generalized A, B, C, D constant, and this is the value of A, B, C, and D. And most important is you can see the value of VS, which is sending end voltage. The value is 94575.013574, and the second is IS, which is sending end current. The value is 215.075.475, and the third is the value of regulation, which is REG. The value is 28.187013, and the last is efficiency value, which is 88.409964. So You can see here the workspace of transmission line. So that's all for simulation of medium transmission line. That's all for me, and thank you.
Assalamualaikum and a very good day. My name is Ismail bin Muhammad Abdul Wahab and my matrix number is CE200111. I will presenting for group number 1 and I am presenting lab 3, power system lab 3, Y bus matrix. Okay, so let's move on to our lab. So we are using MATLAB software and we use the program from that is given from the lab sheet. So this is the program and we transfer it to MATLAB script editor. And as you can see here, this is this part is for input declaration, and this part is for the matrix part or the output, you can see as output. So let's run this program. Okay, so first we need to give input for the number of buses and we only need to follow this table. Okay, so the number of bus is 3, as you can see here. So we just input 3 and number of impedance is also 3. So first for this for line number 1, starting bus is 1 and the ending bus is 2. The series line impedance is 0.1 plus 0.3 I. So this is stated J, imaginary number, but for MATLAB imaginary number is I. So 0.3 I. Then line charging admittance is 0.02. 0.02. Next is for line number 2, starting bus is 2 and ending bus is 3. Ending or receiving bus is 3. The series line impedance is 0.15 plus 0.5 I and line charging admittance is 0.0125. Okay, last but not least is line number 3. Starting bus is 3 and ending bus is 1. The impedance, the series line impedance is 0.2 plus 0.6 I. And line charging admittance is 0.028. So as you can see here, this is the Y bus metric for the data that is given from the lab sheet. That's all from me. Thank you.